Hey, what's up guys? This video is for section 3.5 arithmetic sequences and linear functions, and this is the second part. So if you guys haven't watched my first video, go ahead and do that right now so you understand what is a sequence, and then you guys can come back to this one to see the rest of the examples. So now that you guys know what is the common difference in a sequence and what's happening to the terms by using the common difference, we can actually now see or look at a general rule to find any term in an arithmetic sequence. Now notice that on the top here it says NTH, the general rule to find NTH term of an arithmetic sequence. What this means, guys, NTH, N can be any term in that sequence. So we can say the 7th term, the 11th term, we can say the 27th term, you guys can say the 117th term, the 1211th term. So no matter what term, nth term we are looking for, we can use a specific formula or rule to find that value, that number. So the general rule is A sub n equals a sub 1 plus n minus 1 inside parentheses times d. So what this is, a sub n represents a term that you found. So let's say that n equals 10. So we found the 10th term. N is 10, it is the 10th term. A sub 1 is my first term. N is the same n as this one. So if this is 10, this one has to be 10. So that's the term that we're looking for. N 10, or might be 17, it might be 27. Minus 1, you always subtract 1 here, and d is your common difference. So this formula here helps you find any specific term in that arithmetic sequence. So that's what we're going to use. We are going to use the sequence, the formula, to find a specific term, and then I'm going to show you guys how we can relate that to a linear function. So this example number 3 says, write an equation for the nth term of the arithmetic sequence, then graph the first 5 terms of the sequence. So we want to write an equation of the nth term. So that's the rule. That's the actual formula that I show you guys. And I'm going to write it down again so you guys can have it on the screen. So using this formula, a sub n equals first term plus n minus 1, the quantity of n minus 1 times the common difference. We are going to substitute what we know. We know the first term in this sequence. The sequence is 3, 7, 11, and 15. So my first term is 3. I can find the common difference. So I have to find the pattern. And then I'm going to substitute to find that equation of the arithmetic sequence. So let's write that down. A sub 1 equals 3. So there's my a sub 1 here. My common difference is going to be my second term minus the first one, and that's how you find d. So d equals 4, or sometimes you can actually just look at the pattern and find that value, the number. So we are adding 4 every time, and you guys can check 3 plus 4 is 7, plus 4 is 11, plus 4 is 15. So all we're going to do is we are going to substitute the values, not the n, because we are not looking for a specific term. So n is going to be just n, but we are going to substitute a sub 1, and we're going to substitute the common difference. So when I substitute, I have a sub n equals a sub 1 is 3 plus the quantity of n minus 1, and my common difference is 4. But we're not done. You guys actually have to simplify that equation. So I need to distribute the 4 into the parentheses. So I have a sub n equals 3 plus 4n. You guys multiply 4 times n, and then you guys multiply 4 times negative 1, and that's going to be minus 4. We have like terms, the 3 and the minus 4, so you guys will combine. But you always want to start with the variable that has, the coefficient with the variable. So the 4n, the variable needs to go first. So positive 4n, and then we have minus 1. You guys combine the 3 and the minus 4, that's negative 1. So what this means, guys, this formula actually helps you find any term in this sequence. Notice that we can only see 1, 2, 3, 4 terms. But since it goes to infinity, that means that it's infinite. You guys can find the 5th term. You guys can find the 9th term, 11th term, the 10th term, the 20th term. Whatever term you guys want to find using this formula is going to give you guys the answer. And just to show you guys, I'm going to show you that it works. So let's say that I am looking for the 2nd term. So I know the 2nd term is 7. But if I put n equals 2, 2nd term 2 into the n, 4 times 2 is 8. 8 minus 1 is 7. If I want to find the 4th term, notice 1, 2, 3, 4. So 4th term is 15. But if I put a 4 for the n, 4 times 4 is 16, minus 1 is 15. So it works. So this one is the equation for this arithmetic sequence. Now, every sequence has a different formula, a different equation. You just have to be careful on when you guys multiply, distribute the common difference, and you guys combine like terms. But every sequence will have its own equation. Now it says here, so that's the equation, but it also says that we want to graph the first 5 terms of the sequence. When you guys graph it, I'm going to use a coordinate plane right here, and I am going to have my x-axis and my y-axis. So let me label my x right here, my y-axis right here. I am going to plot the points on the coordinate plane. Now, how do you do that? Well, you actually have to convert your sequence into a table, and then you guys can actually graph it. So what's a table? Well, my table, I'm just going to zoom out here because I have to do my table on the side. I'm going to convert my sequence into a t-table. My t-table are going to be the x and the y values. Now remember that x is one column, the y is the second column. But we don't actually say x and y in sequences. I'm just put that right there so you guys can see that we do have an x and a y. But what we say is we have term for the x value and a number for the y value. So the first term is 7, so that's the number 7. Or the second term is 14. I'm just making up numbers. Now in this sequence, in this specific sequence, my first term is 3. So I'm going to put first term 1 is 3. My second term is 7. My third term is 11. My fourth term is 15. Notice that these numbers right here are the actual numbers from the sequence. Those are going to be my y values. So we have a 3, 7, 11, 15. I know my common difference is 4, so my next term, my 5th term, is going to be 19. So let me put 5 here and a 19 over here. So when you guys graph the points, you're going to plot the points as regular points, or the numbers as regular points. You have x1, so you guys go 1 to the right, 3 up, and then you guys 2, 7, 2 to the right, 7 up, and then 3 to the right, 11, and you guys keep doing that, and you make points. So let me do that right now. Since I don't have an actual coordinate plane, I'm just going to estimate. So I'm going to say 1 is here, there's the 1, and 3 is right here. So I'm going to put 1, 3. That's my first point. Actually, let me change colors. Let me put red. The next one is 2 and then 7. So I'm going to say 7 is right here. So 2, 7. The next one is 3 and we have 11. So I'm going to say 11. So there's the 3. 11 is right here. So I'm going to put 3, 11. And the next one will be 4. And we have 15. So I'm going to say 15 is right here. There's the 15. And we have 4, 15 is right there. I'm just going to put the 4 here. And then the next one is 5. And we have a 19. 19 is going to be way up here. And we put the point right there. Now you're not going to connect the points because this is not an actual linear function. But if you guys notice, the dots, now this is not perfect, remember, but the dots actually align like a linear function. You guys have a linear equation. And just to open you guys your mind, just so you guys can see, this equation a sub n equals 4n minus 1 can actually be compared to y equals mx plus b. This is your slope, 4m, and this is your y-intercept, -1. So you guys can see how to graph the actual line using the y equals mx plus b, which is a linear function. So that's why we say an arithmetic sequence is related to a linear function. So first of all, you guys need to find the equation. And using the equation, you guys can find any term in that sequence. And you guys can also graph your numbers, your actual sequence. All right, so let's try this one here. You guys have an equation. We want to write the equation. And we have a 2, a -1, a -4, and a -7. Once again, I'm just going to circle right the equation of the nth term. So let me write down the formula, the actual rule for an arithmetic sequence. So what I need is my first term in that formula. So my a sub 1 is 2. So there's a sub 1. My common difference is going to be my second term. So this is my second term right there. -1 minus the first term, which is 2. So this one is actually -3 for my common difference. So I am subtracting 3 every time. So when I when I substitute the first term and the second and my common difference, I'm going to have a sub n equals a sub 1, which is 2, plus n minus 1, and my common difference is -3. Now notice I'm going to put my -3 in parentheses because you guys need to understand that you are multiplying all of this, n minus 1, times the -3. So you're multiplying these two. If I don't have parentheses, sometimes students think this is a minus, you're subtracting 3. You're not subtracting, you're multiplying. So now I'm going to distribute. So you guys multiply, and you have to be careful with the signs. I'm going to bring down the a sub n here equals 2. We have a -3 times a positive n. That's going to be a -3n. And when you guys multiply a -3 times a -1, that's going to be a positive 3. You guys combine like terms, the positive 2 and the positive 3. Remember to always start with your variable. So we have a -3n, and we have plus 5. So this right here is your equation for this sequence. A sub n equals -3n plus 5. That's the rule. That's the nth term. Now, once again, you guys can relate it, compare it to y equals mx plus b. So you guys have a negative slope, -3, and you guys have the y-intercept as 5. But we want to graph it. So let's go ahead and make our t-table, and then we are going to graph the points. So for my t-table, remember that we don't really use the x and the y. I'm just going to put here my term and my number for that term. So my first term is 2. My second term is -1. Third term is -4. Fourth term is -7. And if you guys want to keep going, remember that you guys are subtracting 3. So for -7 minus 3, you guys will get -10. So my fifth term is going to be -10. Now you guys can actually see the pattern here. Let me just divide the numbers. Let's separate those numbers here. If you guys look at the numbers for the terms 2, -1, -4, -7, -10, you're subtracting 3 every time. And these are the terms, the first term, second term, third, fourth, and fifth. So we got our t-table. We know what numbers to graph. So let's go ahead and make our coordinate plane. And there's my coordinate plane. And once again, I am going to just estimate for those points. In my class, I'm actually going to give you guys a graphing paper, a coordinate plane, so you guys can make it look nice. But here, I'm just going to go to my first term right there. And I'm going to go to +2. So 1, 2, and it's right here. My second term is right here. The x is 2. Let me just put it here so you guys know this is your x, your terms, x values, and this is going to be your y values there. So my second term is -1. So -1 is right, let's say right here. That's -1. So I'm going to put a point right here. The next one is my third term is -4. So I'm going to say -4 is right there. That's a -4. So let me put a point right there. And then my next one is my fourth term is -7. So right here. So -7 I'm going to say is right there. And you guys make a point right here. And my next term is 5. So -10 is around there. So -10. And we have our point right there. Now I am just graphing 5 because that's what they say. You guys want to graph the first 5 terms. Might say the 6th, 7th, 8th terms, but usually we just go to the 5. So not perfect, but if you guys actually do this in graphing paper, it's going to be more accurate. And if you guys connect, you're not going to connect the points because this is not an actual linear function, but it is related. It's very similar to a linear function because the dots, they align as a linear function. You guys have the actual line and it's going down, so that's a negative slope, and that's where the -3 comes in here. -3 is your negative slope, and your y-intercept is 5. We don't have the y-intercept here, but we know that it's going to cross at +5. This is 1, 2, 3, 4, 5, so it's going to be right here. +5 will be your y-intercept, but they're not asking for that, so we just have our sequence in the graph. All right, and the last one I'm going to show you guys is actually an application problem where you guys will have to find the equation, the nth term rule, plus you actually have to use that equation to find a specific term. So let's go ahead and read what the problem says. Pepito is stacking boxes of tissue for a store display. Each row of tissues has 3 fewer boxes than the row below. The first row has 30 boxes of tissues. Now, first of all, we have to know what we have and what we can use for our formula. So here it says that each row of tissue has 3 fewer. So that means that it's subtracting. It has 3 less than the previous row. And the first row has 30 boxes. So right away, I know a couple things. I know my first term. My first term is 30. Right away. The first row has 30 boxes. And my common difference, that's going to be -3. And I'm saying negative because it has 3 fewer. You are subtracting 3 every time. If you say it has 3 more than the previous one, then you guys are adding 3. But right now, you guys are subtracting. So part A says to write a function to represent the arithmetic sequence. So that's the same thing as the equation, the function. But when they say function, that means that we have to use function notation, which is f of x. So first of all, I'm just going to write down the formula again for the nth term. And I am going to zoom in here so I can have a little bit more space. So I am going to just substitute what I have. So a sub n equals my first term, which is 30, plus we have the n minus 1 times the common difference, which is -3. You guys are subtracting 3 every time. I'm going to simplify, so I'm going to distribute here. So a sub n equals 30. You guys multiply the -3 times the positive n. That's going to be -3n. You guys multiply -3 times -1. That's going to be a +3. So a sub n equals 30. Oops, sorry. Let's go ahead and combine like terms. I forgot. 30 and +3. But you always start with the variable. So we have -3n plus 33. Now, that's the equation. Now, function notation is when we actually use f of x. So f of x equals -3n plus 33. But let's go ahead and change this x into n because we do have an n here. So I need to have the same variable. Every time you guys have function notation, whatever variable you guys have here has to be the same variable as over here. So you can change it to n. So I'm going to change that to n so we can have it in function notation. So f of n equals negative 3n plus 33. So we got the function right here. So now we can actually find any term in that sequence. We can find the second term, third term, fourth term, and so on. So let me just zoom out here because I need to look at part B. Part B says how many boxes would there be in the 10th term? Okay, so my 10th term, what that means, 10th term is what we are looking for. How many boxes are in the 10th term? This is a time where you guys say n equals 10. That's what we're looking for. We know that n is going to equal 10. If they ask for the 9th term, n equals 9. If they ask for the 3rd term, n equals 3. But right now we're looking for the 10th term. So in this formula right here, you guys are going to substitute. Actually, we're going to use this one here because this is the function notation, but we're actually looking for a specific term. So we're going to use this one, the actual nth rule. So the nth rule here, a sub n equals negative 3 times n plus 33. I'm going to substitute 10 into the n. So I'm going to have a sub 10 equals negative 3 times 10 plus 33. So a sub 10 equals, you guys multiply negative 3 times 10, and that equals negative 30, and negative 30 plus 33 is positive 3. So on the 10th term, you guys have 3 boxes. Now, you guys can actually use a table, and I'm just going to go a little bit further. It doesn't ask for a table here, but you guys need to understand what all of this means. So in your T table, you guys have the number of rows. So those are going to be your terms. I'm going to have row here, and I'm going to have boxes, the number of boxes over here. So I know that, and I'm just going to put here my term, my first term, second term, and the number of boxes. Let me put parentheses here because that's what it means. So in my first row or my first term, I have 30 boxes. Since I'm subtracting 3, it says there that it's 3 fewer boxes on the next row, the row below. So my second row or my second term is going to be 27. My third row is going to be 24. And then you guys keep going, keep going, keep going. And when you guys get to the 10th row, you guys will have 3 boxes, only 3. Now, common sense, if you guys go to the next row, let's say you guys have 11 rows. My 11th row, well, that's going to be 0. I don't have any boxes in the 11th row. It's going to be empty. And common sense, guys, if you guys go to the next row, mathematically, that's going to be negative 3. Because if you subtract 3 every time, 3 minus 3 is 0. 0 minus 3 is negative 3. So my 12th row is negative 3. Mathematically, it's negative 3. But reality, when you guys go to a store, any store, and you guys look into the shelves, the rows, you're not going to find negative 3 boxes in that row. It's just going to be 0, empty, and that's it. Or you might have 3 boxes, 2 boxes, 1 box, but you guys will never have negative number of boxes. So reality, you guys cannot have a negative value. But mathematically it works. You guys can actually go down and you guys can say negative 3. But in context of the problem, for this T table and for this problem, you guys can have negative numbers. Alright guys, so this concludes my video for this section 3.5, which is arithmetic sequences as linear functions. If you guys like my videos, you guys can hit that like button. And if you guys want to subscribe to my channel, go ahead and subscribe. Make sure you guys practice, and I'll see you guys later.